Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics. Today we will continue with regression modeling, and that to continue with the process of the bivariate estimation. And in the last lecture we have discussed the problems relating to airline cost determinations. The objective of this problem is to predict the airline cost subject to airline passengers. So, that means there are a couple of factors or variables which can affect the airline cost, but number of passengers is one of the most important variable that can affect the airline cost drastically. So, that is how in the last lectures we have discussed this problem, and for that we have used simple regression modeling, that is the bivariate econometric modeling, where y is the dependent variables and that to the airline cost, and x is the independent variable that to the airline passengers. And since we are dealing with linear regression modeling, we have used a linear regression modeling that to y as a function of x, and that to the simple equation is y equal to alpha plus beta x, where y is treated as a airline cost and x is treated as a airline passengers. And having a particular sample we have already discussed in details. And in the last lectures I have given you clarity about the mathematical procedures and that to the application of the technique called as a OLS, that is the ordinary least squares, and the process of OLS is to minimize the error sum squares to get the values of the unknown parameters, and these unknown parameters will help you a lot to predict the airline cost with respect to airline passengers. We have already discussed all these details, and right now we will just see how software can help you to calculate these parameters, and that to bring the predictor line through which we can predict the airline cost subject to airline passengers, and then check the kind of errors or the details before you go for the predictions and as per the requirement of this transportation sector. So, let us move to this. So this is what the kind of problem. So, now we have the problem like this. So, this is the number of passengers and this is the cost, and we declare this is a dependent variable and we declare this is the independent variable, and as a result we have already discussed the manual procedure through which we can process and get the values of these parameters, unknown parameters, that to alpha cap and beta cap with the help of airline passengers data and airline cost data. And without any softwares, you have to follow this particular mathematical procedure to have these figures. So, now with the help of softwares we can easily get these parameters value and the kind of regression line to predict the airline cost subject to airline passengers. So, let us see how is this particular structure. So, as usual the problem we have discussed. So, this is the airline passengers and this is what the airline cost in $1,000, and we need to regress y upon x, where y is the airline cost and x is the airline passengers, and this is what declared as a x and this is declared as a y, and your linear regression modeling will be y equal to alpha plus beta x, and our job is to find out y cap, that is the predicted y or regression line, which is equal to alpha cap plus beta cap x, and to know the alpha cap value and beta cap value we use OLS technique, and then the process is to minimize the error sum squares, and the way you will process you can get the values of these parameters. and mathematical we have already checked and we have also tested and obtained the values with respect to this data. So, now same data we can use through a software and try to have these figures, so that we can get to know how is this particular process, because this is a small data set and that too with 2 variables. It is easy to process manually, but when your data size is substantially very high, let us say 2000, 3000 like this, and when we are dealing with multiple regression modeling or multivariate regression modeling, that times you cannot easily handle the problem manually, and the requirement of software is very significant during that time. So, let us try to acquainted with the kind of software, how to deal with these problems and to get these requirements. So, we can use standard econometric software, but in the meantime, since it is the base beginning, so I will use Excel, because Excel spreadsheet has a data analysis package, and the entire engineering econometrics more or less covered and bounded with regression modeling, and Excel data analysis package is having a regression technique component. We can directly use Excel and get the values of these parameters, and later on the same problem we can actually handle through different softwares, and then check the robustness of the softwares and the kind of results. So, here in the Excel spreadsheet, after entering the data, you just click the data here, then the moment you will click the data here, so you will find there is in the extreme right there is a data analysis pack. So, you just click, then you will get the box like this, and the box will give you the there are lots of things you will find here, and starting with correlation, covariance, descriptive statistics. So, that means technically we can check whatever we have discussed earlier, descriptive statistics. Let us see one by one. So, this is descriptive statistics. So, now for that you can give an indication about both the variables and then put OK. So, it will give you the OK. So, this is what the descriptive statistics. OK. Summary statistics. Okay. So, this is with respect to x variable, and these are all summary statistics. These are all summary statistics, and for x variables, and again you can go to the kind of cost data again, then again you go to the data analysis package, that to descriptive statistics, and change the variable options. You can give the indication about the second variables, and again put OK, and you will get the OK. So, this is what the range, put OK. So, this is how the second variables range. OK, and again go to the cost data and data analysis package. So, this is how the descriptive statistic figure, and again so you can check the covariance, you just give the indications, and in that case both the variables simultaneously can be indicated, and put OK. You will get the covariance figure here. So, this is the covariance matrix, and for here from this covariance matrix it is clear that y and x are positively related, and again so we can test through correlations. So, the correlation can normalize the particular structure. So, again go to the cost data, and then you can indicate the variable range, and you will get this is what the correlation matrix, and here you will find the correlation between x and 1, correlation between y and x is actually coming 0.95. that means they are highly correlated. So, that means the identification of airline passengers to airline cost determination is very perfect, theoretically supported and statistically also supported. So, now our requirement is not to check the only relationship, our check is to predict the airline cost with respect to airline passengers. So, that means technically before we go for the prediction of airline cost with airline passengers, we like to check the details about the kind of descriptive statistic, that is the y x variables, that is the airline passengers. So, the mean this is the mean figure, standard deviations, median, then spreadness, skewness, range, minimum, maximum, sum, count. So, to count is the number of size. Similarly, we have the information about the second variable. So, these are all the variables against mean, median, modes, then range, maximum, minimum, count. So, 12 here the sample size is also 12. So, that means this will give you some kind of background. Since the range is actually 36, so that means it is clear that the items or informations are not same. So, there is a difference, and that will be also verified through the standard deviation, which is not exactly equal to 0. This is for variable 1 and this is for variable 2. And again in the variable 3, we in the third case we have calculated the correlation matrix, where we have found there is a significant relationship, and that relationship is positive. In fact, this is what the first hand output that can be statistically again checked and to know the details. And in fact, before we go for airline cost predictions, so we have the clarity both theoretically with the descriptive statistic, with covariance matrix, with correlation matrix, so with the data visualization again. Now we will check how is the kind of modeling procedure through which you can we can actually predict the airline cost with respect to airline passengers. And for that, the standard technique will be regressions. Again, you just go to the data analysis and then you choose the regression. So, this is what the regression, and now in the regressions we will find there are two boxes here. So, input y range and input x range. So, y range is the dependent variable and x is the independent variable. So, now in this case this is declared as a x and this is declared as a y. So, as a result, so you will give an indication about the y series and x series. So, since it is the dependent variable, so we can give the indication like this, and then this is for the x indications. We will give the x indication here, and then what will you do? We will just put OK, and you will find the regression output. In this particular, this is what called as a summary of regression output, and that too with the help of data analysis package through Excel softwares. And till now whatever we have discussed, that is with respect to this portion only. Okay, so this portion only. So, that is the how to get the alpha coefficient, that is 1.57 and x variable 0.04. So, now if you will go to the kind of slides, you will find the results are more or less same. Okay, so this is where we will get beta coefficient 0.0407 and beta coefficient is 1.57. This is alpha and this is beta, and same thing we obtained here. Intercept, that is alpha coefficient is 1.57 and beta coefficient is 0.0407. So, that means whatever answers we have obtained through the process, manual process, it is actually same with the help of also softwares. So, that means software now to have these values through software is very very effective, because within less times you will get these results and then can then analyze as per the particular requirement. So, now in addition to these values of alpha coefficient, beta coefficient, there are couple of other items are available in the Excel spreadsheet, that to the data analysis package. but these are all not unnecessary component. These are all useful for the kind of regression modeling, that to predict the cost factor, airline cost with the airline passengers. But the interpretation of these items are different. Over the time we will connect and discuss, but in the meantime, so we get to know how to get the alpha coefficient, that is the intercept, and how to get the beta coefficient, that is beta slope coefficient, that is beta. And we are acquainted with the system manually, and we are acquainted with the particular process again through softwares. So both the cases the results are matching, and it gives the kind of structure to predict the airline cost with respect to airline passengers. So that means from this result we can have the predicted lines where y equal to 1 plus 57 plus 0.041 x. So that is what the predicted line. So that means technically so your predicted structure will be like this. This is the predicted line, and of course the data point are looking like actual data point will be like this, and this is y cap, and that too it is nothing but intercept is 1.57 plus this is 0.041 x. So this is what the predicted line. So now you put x value, any x value, you can get the y predicted. So that means technically that is what is our objective. So if the passenger will increase or decrease, what should be the airline cost? So on that basis we can apply some kind of strategy that may be helpful for the airline industry or as per the kind of problem requirement. But you should know equally the process through which you can obtain these figures, right. So that means technically we are now acquainted with the system, how to obtain the values of these parameters through the through the process of OLS, and that too with the help of manual process, and again through the help of softwares. So now after getting these predicted lines, so next job is just to check how is the kind of behavior. So that till now we have discussed this much, and now this is what actually the predicted lines, where we have the predicted lines, that to 1.57 alpha coefficient and 0.041 x. That is what the black line indicates the estimated line, and these are all actual lines. If we will join all actual data points, it will be like zigzag, but the predicted line will be straight lines, and that is what it is called as a line of the best fit. So without putting the x value, you just extend these lines, you can get the predicted values of y corresponding to the x indication. So now from this estimated values alpha and beta, we can obtain the error terms, because initially we start with the process that y equal to alpha plus beta x plus error terms epsilon, and your y hat equal to alpha hat plus beta hat x, and your error terms epsilon will be y minus y hat. So that means, so this is the actual and this is the predicted. So that means for let us say x is a variable here and y is the dependent variable, and y predicted, that is the predicted dependent variables. So now for every x, let us say x1, so we have y1 and we have y1 head. Similarly for x2 we have y2 and y2 head. So that means for every x we have actual y and predicted y. So now the difference will give you the error terms e or epsilons, that is y minus y1 minus y1 head, then y2 minus y2 head, and so on. Then you can create a series. So this is how we can obtain the error terms. So initially we start with the y and x, and over the process you can have the Excel sheet y x, y cap and error terms. So now as per the requirement of the regression modeling, what we have discussed earlier, there is a certain checks before the process and there are certain checks after the process. And before the check we have already discussed in details, that is the uniform sampling, then the minimum sample size, the kind of theoretical understanding. So, these are all we have already discussed, but after the process of estimations we like to check certain things before we go for the predictions and the kind of forecasting. The first check is the error component. So, ultimately the requirement is to check whether the mean error is equal to 0. That means sum of the error terms should be equal to 0. So, from these figures you can we can easily understand that some of the data points are above and some of the data points are below. So, now any in the above data points will give you the positive error sum, that is the summation of error terms positive side, and this here will give you so error terms negatives. So, these two should be matching, so that this total error will be equal to 0. So, if that is the case, then this particular line can be declared as the line of the best fit, otherwise it may be the estimated line, but it cannot be considered as the best fitted line. So, technically the process of OLS is that it will be the line of the best fit, but there may be some error because of lots of other issues like different functional form, the variable inclusion, exclusion, sample size, so many things are there. So, that the particular predicted line may not be the best because of these regions, but ultimately whether the particular predicted lines will be called as line of the best fit. So, we have to check certain things, then finally you can give the signal that yes, as per the obtained line from the OLS will be declared as the line of the best fit, and then you can go ahead with the predictions as per the particular engineering requirement. So, obviously the process is like this. So, you have the predicted line here, and now what will you do? So, you just check the kind of regression output. This is what the regression output which you just initially tested through Excel software, and what we have here. So, till now we have discussed up to this much. This is the beta this is the alpha coefficient and this is the beta coefficient, and in addition to these alpha coefficient and beta coefficient, we have actually this much of extra outputs, and these are all extra outputs. Till now we have not discussed anything about all these items. In the later stage we will discuss, and all are highly required to validate and to justify the line of the best fit, and that too the line which can predict the airline costs with the availability of airline passengers. That means we like to predict y subject to the x availability. So, now what are these items? Will means the other items, that is the estimated regression requirements. So, we will discuss in detail in the later stage. In the meantime, we just like to know the something about the line of the best fit, that to check the error procedures. What we have discussed in the last lectures, that we have x information, we have y information. By using OLS process and the kind of fixing the linear regression modeling, so we can obtain the y predicted, which is nothing but alpha heads plus beta head x, and alpha head equal to y bar minus beta head x bar, and beta head equal to covariance of x y by a sigma square x, variance of x, and then we can actually generate this predicted line. Now, with the help of y actual and y predicted, we can get the error component, that is the difference between y actual and y predicted, y actual, y predicted with different sample points. So, as a result, if you check the residuals, you will find some are positive and some are negative. For instance, this is positive, this is negative, this is positive, this is negative, this is positive, this is negative, this is positive, this is negative. again this is positive, this is negative, this is positive, this is positive. So, that means more or less some is up, some is down. So, that means it is very much consistent as per our requirement, because the line of the best fit should be in the middle of these points. As a result, one will be positive, one will give you positive error, another will give you negative error, and if you take this sum should be close to 0. In fact, this is the error sum, and it is coming minus 0.001. That means it is close to 0, and the it should be exactly equal to 0, but due to this round up rules, so we are obtaining sum of the error term equal to minus 0.001, which is very close to 0. So, that means technically the estimated lines, and that to the values of these parameters alpha and beta heads are perfect in one sense, but we cannot say absolutely perfect until unless you go through other checks. In the first check, that is with respect to error term check. So, that is the sum of the error terms should be exactly equal to 0, which is actually happening here. So, so the declaration is that the values of the estimated parameters which we obtain through LS mechanisms are perfectly okay to predict the airline cost with respect to airline passengers. Now, with each processing, so what will we do next is to check the error behavior. Of course, the error sum is actually coming 0, but we like to check the behavior of the error terms with respect to the x and y involvement. So, in the next slides we will check the kind of plotting. This is what the plotting of residuals and a number of passengers and with respect to the residuals. So, because it is the number of passengers which can decide the airline cost. So, we will find the error points are drastically different. Okay. So, some error point is here, some error point is here, some error points are here, some error points are here. It is a kind of heterogeneous kind of spread. So, it is not showing any kind of direct functionality, and this will give you some kind of indication that the model is somehow okay. The one way to justify is that more or less same number of points in the upside and some of the numbers are in the downside. So, we have this sum that side and we have this sum this side, and both should actually matching each other. That is how the indication here. That means looking these figures, it seems that it is somehow okay to go for the predictions, and then in the next slides you can actually check the means this is what actually the kind of behavior, and if you plot these points, so it looks like nonlinear residual plotting. Sometimes it is coming the residual plotting, and this is another way to justify the nonlinearity. So, that means technically like we have checked the data visualization to know the nature of y and x. So, next step after the estimation is to check the error sum and the plotting of the error term, whether the error terms are equally linear one or it behaves like non-linear. If the model is linear, then error should be actually linear. If it is non-linear, then the modeling process will be different, and that too it may affect the process of reliability check, and that too this is how the error behaviors. Of course, what we are supposed to do here, we are checking the error sum, which should be exact, which should be come to 0, and then we check the plotting of the error terms, which will give you the functional forms, whether it is a linear spread or non-linear spread, and again we like to check the error variance. Okay. So, which is nothing but sigma square u, and how to get this error variance we will discuss in details later, but the error variance should be actually homogeneous. If error variance will be heterogeneous, then it will give you some kind of econometrics issues or some kind of statistical issues. That's what is called as the component called as heteroscedasticity, which we will discuss in the later part. But one of the requirement of this particular OLS processing is that your error variance should be homogeneous in nature to justify the fact that the particular estimators or line of the best fit, line of the regression is the best one. So, for that the error variance should be plotted and check whether it is having a homogeneous spread or heterogeneous spread. If it is a homogeneous spread, it is good for the OLS mechanism. If it is not homogeneous spread, it will be going against the OLS estimation process. So, now if it is supportive, then we can go ahead with the predictions. If it is not supportive to the OLS, then we may change the particular route and then we will go for the particular another procedure to predict the particular requirement. So, we will discuss in details in the later stage, but it is the mandatory requirement that to check the nature of the error component, that to the sum, the plot nature and the kind of error variance. So, likewise this is another kind of plottings to check whether the error terms are actually completely independent to each other and their error variance are homogeneous in nature. Error component the individual kind of natures and their variance. So, the actual positions and the variance position both are different. Error variance is something behavior of this particular plotting, but the positioning of this error term should be completely different with respect to y and x. Okay, so this should be very much consistent as per the particular requirement. This is actually the what we can call as healthy plotting. So, as per the OLS requirement, if the plotting of the residuals will be like this gives the signal that they are independent and the error variance is somehow homogeneous in nature. If that is the case, then again you will go ahead with the predictions and the line will be declared as the best fit line or best fitted line. So, if the error sum is not coming 0 or the error variance is not homogeneous, then by default the particular lines which you consider the line of the best fit may not be very handy to go for the predictions for this particular problem to predict the airline cost with airline passengers. Okay. So, these are the process through which actually we can predict the airline cost with respect to airline passengers. That means technically in these lectures we get to know how to estimate all these parameters manually and through softwares and get the estimated parameters value and the line of the best fit and obtain the predicted y, obtain the error terms and checking the behavior of the error terms. And these are the minimum requirements you are supposed to do before you start the process of predictions and the forecastings. Then in the next class we will continue here, and that too we will check the reliability of this particular estimated model. Of course, we have slightly checked the reliability with respect to error terms, but there are certain other items we are supposed to check before you start the process of predictions and the kind of forecasting as per the particular engineering requirement. With this we will stop here. Thank you very much. Have a nice day.